is about ARM data flow model. All information is taken from ARM System Developers Guide by Sloss, Symes, and Wright. We'll start with a flow chart which explains the data flow in the ARM processor. Starting with data, as you can see from the top, the data can be either an instruction or a data that has to be processed. So if it is an instruction, it is decoded by an instruction decoder. For other data to be processed, it is first processed by sign extend block, which will convert and align the data to 32 bits. The ARM processor registers are 32-bit, but the input data itself can be 32 or less than 32. In those cases, the sign extend will make all the incoming data as 32-bit. The data is read into the register file, and there are 16 user registers which are named as R0 to R15. After being read into the registers for further processing, the data can be given to arithmetic logic unit, the ALU, or it can be acted upon in a combination with barrel shifter and MAC, which is multiplier accumulate unit. You can see that Rn and Rm is representing the data present in the registers Rn and Rm, and it is flowing through the bus A and through bus B to ALU and barrel shifter. Alternatively, the bus A and B also can give the data to multiplier accumulate unit. Data when once processed by these components, it can be given and stored to the uh, result register, which is nomenclatured as RD. For instructions and further execution, the output from the ALU and MAC is given to an address register, which also is incremented by the incrementer so that the execution can proceed to the next execution address. And this is essentially the pictorial description of the ARM data flow model. Now we will see into details about each of these executions. As we have seen, the data is entering the processor core through the database. If it is an instruction, it is decoded by the instruction decoder, or it is then uh, processed as a data for processing. One detail here is that the architecture can be von Neumann, and in this case, the data and the instructions share the same bus. Whereas in the Harvard implementations, there are different buses for data and instructions. The instruction decoder itself translates the instruction and identifies instructions from to a particular instruction set. The registers and memory operations use the load and store architecture. Load instructions copy data from memory to registers, and store instructions copy from registers to the memory. Data processing is carried out only in the registers. The ARM processor does not operate directly on the memory. The sign extend hardware, it is a unit that converts all the input data to 32-bit values if they are not 32-bit. The register file is a bank of registers which are 32-bit, and the instructions will treat that the registers have a valid signed or unsigned 32-bit values, and the registers themselves, Rn and Rm, are representing the two registers which will be operated by the ARM processor. The source operands are read from the register file, and buses A and B are used. to read the data. RM can be processed in barrel shifter before it enters the arithmetic logical unit. Barrel shifter and ALU can calculate wide range of expressions and addresses. Once the value is computed, it is denominated as RD, and it is written back to the register. ALU and MAC compute result with RN and RM. The address which is generated by ALU in case the data is an instruction rather than processing, it is stored in the address registered and then it is broadcast on the address bus. An incrementer is a unit that updates the address register, and core the reads and writes the next register value from the next sequential memory location. This location is given by the address register. Thus, processor continues the execution in the workflow that is described above.